The U.S. Matific Math Games are coming this February. Stay tuned at the end of the show to learn how you can have free access to the full Matific platform, and your school can enter to win up to $50,000 in cash and prizes, all while your kids learn about math. Math and Computational Thinking in Elementary School, Episode 249.
The 10-Minute Teacher Podcast with Vicki Davis. Every weekday, you'll learn powerful, practical ways to be a more remarkable teacher today.
Today, we're talking with Stephen Floyd from London, Ontario, Canada. He was named as one of 10 2017 Computer Science Teachers Association Awards for teaching excellence. And today, we're going to talk about teaching computational thinking for K through 6. Now, Steve, a lot of folks talk about computer science and teaching coding with the older levels, but what kinds of computational thinking should we be teaching the younger kids?
It's been actually really quite interesting. We're looking at some of the concepts and some of the things that students are doing in the older grades. And I know for myself, with a few of the projects we've been working on, we've been saying, can we get the younger students to engage in these same types of thinking? So obviously they're doing simpler tasks. Maybe they're not as complex and in depth, but the type of problem solving they're doing, the type of debugging, the type of they're having to sequence their instructions, they're having to reiterate, and they're having to do trial and error. All of those things that we see the older students doing, we're finding that with the newer technologies, we can get these younger students doing the same thing. It's been really interesting.
Steve, do you have any favorite tools that you kind of like for the K-6 crew?
We've been working with the Bbot. It's a small little bee. It's a programmable bee. It just has about 6 buttons on it. You program it to move 15 centimeters forward, or do a 90-degree turn, or to turn left. And then you just hit go, and the bee just executes the instructions. So we've used that with even junior kindergarten kids, where they're usually doing spatial reasoning tasks and trying to get it to go around a grid. We do a lot of work with Scratch Junior, a free app on iPads and things, where the students are doing, you can get an XY coordinate grid on there. Students are doing storytelling, where they're having to sort of decompose their story into smaller chunks and then code the story. Those are the two big ones that we've been using. And then we usually move to Scratch for the grade, somewhere around grade 3 or 4. And that's a nice transition for the students, because it's still block coding, but it adds a little bit more complexity.
I actually have some of my older students do Scratch. It's a great way to introduce all kinds of computer science concepts before you're ready to go into actual coding. Today, they were doing a project, and one of them said, this is math, this is geometry. I mean, there's a whole lot of math in this coding and computational thinking, isn't there?
There is, and it's just a natural fit. Sometimes we're teaching specifically the students to learn coding, to learn about loops, or to learn about a variable. But a lot of other times we're using coding to have students experience math. So in Scratch, you can have the Cartesian planes, or in Scratch Junior, you just have XY coordinates. And it's a really cool way for students to sort of experience math. There's a professor here in London, Dr. Gadanides, and he does a lot of work on math and computational thinking, and having students, instead of kind of write down responses and being told how mathematics works, they're getting a chance to construct that knowledge by using these tools. And it's really, really interesting to see. We even had sometimes students, I think it was a grade 7 classroom, we had a student, this young girl was just so excited, and she called her teacher over, and she started doing a dance when she got the cat to move to the right coordinates. And I thought it was kind of cool, but we see that sometimes in our computer science classes. But the teacher saw me afterwards, and he said he just couldn't believe that she was doing that she sort of saw herself, at least temporarily, as a mathematician, because she had never had that kind of success. It's really cool to see things like that happening.
Steve, do you find that there are teachers that think that kids can't really understand these concepts, like elementary kids really understanding X and Y coordinates?
There are sometimes. We've been doing a lot of sort of getting teachers to just do it. So rather than have these really long sessions where we introduce the concepts and we've got these slideshows and we're explaining the theory behind it all, what we're finding is we get teachers to come in and grab the tools right away, start doing maybe something that's step by step, and then they're quickly, they sort of kind of quickly, they learn it that morning. And so because they've learned it sort of just that morning, first of all, it builds their confidence in teaching it, but also they realize when they go to teach it to the students, they've just learned it themselves. So they're actually a little more prepared to teach it to the students because they can empathize with the learning process. They understand the barriers that students might face because they just faced it themselves that earlier that week when they were learning it themselves. So it's been really interesting. There is that sort of growth mindset you have to instill in them, but telling them to have a growth mindset doesn't always work. We find just handing them the tools, getting them to have some immediate success with it makes them realize that they can handle this.
And there's nothing like when the child says, okay, I want it to go over here, or I want it to go over there. And calculating those X and Y coordinates, which really kids of really most ages can do, them realizing that they can make the physical robot go here or there based upon their program.
Exactly. It's been described, I think it was Seymour Papert that had said these are tools to think with, or objects to think with. That's what these computers are, and that's what these robots are, and that's what these little lines of code are. They're just tools to think with, and the students will type in the stuff to get that student, type in the code to get the robot to here or to there, and it doesn't work. But they're understanding eventually why it doesn't work, and so they're being able to construct their knowledge a little bit, and they're realizing, so that's what X coordinate means, and that's what Y coordinate means. And we're hoping to look into maybe does that transfer onto other tasks. So when they're doing tasks on paper or something that involve X, Y coordinates, having constructed that knowledge with the robot, does that lead to greater success, which would be really interesting to see.
So Steve, you've given us one example of a 7th grade girl. Do you have an example for us where the light bulb went on and you just realized perhaps we're underestimating the abilities of our elementary kids?
We were in a grade 3 classroom and we were doing X and Y coordinates. And a few of the teachers had said, what we had going on where my high school students were teaching the grade 3s. So we had this program where our high school students came in to teach the grade 3s, which was really cool. Our high school students be leaders like this. And we had told the teachers beforehand what we were going to cover. And the teacher said, that's a lot of material. It was a grade 3 class and it's an hour before recess, but we'll see how you guys do. They were just blown away at how quickly the students picked it all up. Because there was time left, I went up to the board and started talking about rotations and translations and reflections to these grade 3s. And I think we called them flips and slides and turns at first. And then by the end of the lesson, the students were using this terminology. The teachers were just amazed. And then even some students would record themselves. So when the cat was doing a rotation, they would record themselves saying rotation. And so at the end, we sent a few students down to show some of the other teachers, and they were just playing their program they're basically labeling with this audio, each of the translations, the reflections. It was a really cool experience for the students and also the teachers there to say, wow, these students, they're covering a lot. And it seems as though they're really understanding it. They're being able to say it in their own words afterwards.
Wow, you're really making us think. So Steve, as we finish up, could you give us a 30-second pep talk on why we need to have coding and computational thinking in the elementary grades?
So there's always that argument for jobs and for the labor market, which is a great argument. We want our students obviously to have skills that they can find employment, and we want sort of the labor market to be full with IT people with IT skills, and that's exciting. That's good. I know a lot of teachers, though, they don't seem to get up in the morning and they're not passionate about their work simply to fill the labor market. They want students developing as kind of human beings, developing as citizens. And I think that's what's sort of underestimated with coding and computational thinking. The natural things that happen, things like innovating and creativity, and the way students right away are collaborative, like almost automatically. If one student has something working and the other doesn't, then they learn to share ideas. The idea with these coding and computational thinking tasks is often there's not one right answer. So students learn that there's more than one possible solution. They learn that they can get feedback right away from their programs. They can try quickly. They say sometimes you fail quickly and you fail cheaply because you can just change the code, try again, change the code, try again. And so it's my hope that students are learning these skills and that they're realizing they can apply these to other areas of their life, that they can be creative, innovative, collaborative, that they can be problem solvers in other areas. The other big one that really interests me is sort of media awareness. Maybe it's media literacy or just knowing a little bit of how the world works. Once you understand a little bit of computer programming code, you start to look at things a little differently. You understand how the traffic lights might be working in your city or how they could work better. You understand why you get certain ads sent to you, maybe an email, or maybe certain things pop up when you're using the internet because you were shopping for shoes the day before. You start to understand those algorithms, and I think it just makes you sort of like a critical citizen, I suppose, a critical thinker. And I think those are the things that we're not quite focusing on yet with coding and computational thinking, that it's definitely beyond the jobs.
And I would encourage all of our listeners to also pick up a book called Humility as the New Intelligence. So basically, the next big disruption of jobs is going to be intelligent machines, and it's going to displace a significant number of jobs. And part of the thesis of the book is that the jobs that will be left will be those requiring creativity, problem solving, collaboration, and working with other people, things that machines cannot do very well at all. And these are the things that we have to teach: how to interact with these intelligent machines and how to program, but also how to do these other things. And I think that it's more than just coding. It's more than just computer science. And Steve, I like what you said about it's not just about, having jobs, all that's important. I think it's about being relevant and being employable, because you can solve problems and you can create and you can collaborate with people as you do these things. So teachers, get out there and plan for computational thinking and coding and adding that to your K through 6 curriculum. Try Matific free now and participate in their math games at coolcatteacher.com/math. Now, Matific is a fantastic site full of math manipulatives, customized playlists of activities to help students at every level master math. This fun and gamified site is one I've been recommending for years. Now, the Matific Games are here. Your students in the United States can compete to win prizes for themselves and your school as they gather stars by completing math activities. Sign up now for the Matific Games at coolcatteacher.com/math. Setup is easy. Just send them your class rosters and they'll set you up in 24 hours. This is a great way to try out Matific, help your kids boost and study math, and have fun at the same time.
Thank you for listening to the 10-Minute Teacher Podcast. You can download the show notes and see the archive at coolcatteacher.com/podcast. Never stop learning.